Hi, welcome to our talk about WebAssembly on the edge. We are going to focus on mixing sandboxing and performance, as in you get both of them, rather than sandboxing or performance, which is what you may normally expect when security gets in the way and slows things down. My name is Brian Sletten. I'm the author of WebAssembly, the Definitive Guide, and I have about 30 years of experience in the industry, mostly focused on next generation kinds of technologies, but several distributed systems have been part of my experience as well.
I'm Ramnivas Laddad. I've been involved in many communities, Spring Framework, Cloud Foundry, aspect-oriented programming, and I'm also a great fan of Indian classical music. In fact, I got introduced to Rust and WebAssembly when I was working on a project targeting Indian classical music learners. Last few years, I've been working on a new project called Exograph, which is a framework to create backend services very easily.
So WebAssembly has become a standard and has been around for about 7 years now. It's been supported by all the major browsers, and most people's experience of it has been about running code in the browser in languages other than JavaScript. But its bigger vision goes beyond that, beyond the minimum viable product, nicely documented in Lynn Clark's fantastic cartoon introduction. But WebAssembly itself provides a couple of core technologies. Now, the original MVP had some limitations intentionally. Things like garbage collection and thread management were left out. But it's a compilation target, so we can take existing code in C, C++, Rust, Go, things like that, and have it run compiled against this target instruction set. But then that instruction set can be converted into a native instruction set by a WebAssembly runtime, and that gives us reasonably good performance. We also have a compact representation of the code that's generated. So it's a binary representation that can be passed around. The modules are more easily transferred, cached, validated in this binary form. And one of the other major portions was the emulation of linear memory, which allows us to attempt to build things like C++ and C pointer arithmetic, which is a big part of what makes those languages both safe or fast and unsafe. Edge computing is a new sort of place where we can put our code. If you're used to thinking about running it on a computer or running it in the cloud as your options, edge computing environments allow us to target a wide range of locations. So it may still make sense for some things to run in the cloud. It may make sense for some things to run on-premise or on device or on a sensor, like an Internet of Things sensor. But for various reasons, we may want to move it closer to the customer for better user experience and lower latency interactions. Or maybe it makes more sense to run it in the cloud where there's large amounts of data and we can kind of spin up additional capabilities as we need to. But the edge continuum allows us to target somewhere in the middle. And one of the technologies that we're going to talk about is Cloudflare Workers, which is an attempt to allow you to target code in one of these runtimes. But it has very different constraints, as you'll hear in a moment.
So as Brian mentioned, WebAssembly offers a sandbox environment and also is a constrained environment. So we're going to try to see how this plays out in practice through this project, Exograph. So Exograph, as I mentioned, is written in Rust, and we will see what are the challenges we had to face and how did we overcome them. So a bit about Exograph itself. So Exograph is a way to allow you to express your domain model. So in this case, we have concept type, we have venue type, we have express relation between them, as well as some access control rules. And once you have this domain model, you run your Exograph server and you get APIs right out of the box. So in this case, right now we are offering GraphQL APIs, but we'll offer REST APIs and other APIs soon. The way Exograph works is you start with your domain model, and Exograph has an Exograph builder, whose job is to take this domain description, parse it, type check it, and produce something called intermediate representation. So this intermediate representation essentially is a digest of all the module information. So what are the queries to be offered? What are the access control rules to be applied? Then Exograph runtimes reads this XOIR file, and at the back end of it, it has database such as Postgres or cloud services, so that when a query is made, in this case, there's a GraphQL query that is asking concerts with ID and title. It will go talk to the backend services, fetch the data, and return it to the users. Exograph, this is going to be our focus. That's the green box, where we are going to focus on how to make it available on edge networks. Exograph currently deploys to pretty much any target you can think of, Docker, as well as traditional server architectures such as EC2, Azure, but also serverless functions, serverless environments such as Lambda, Azure Functions. Our focus is going to be on Cloudflare workers as an example of edge computing. The lessons learned, however, are more generally applicable, essentially any environment where there is a constraints, edge computing like constraints. I will give a quick demo of Exograph. So this is Exograph's playground. And in a way, this is an extreme example of edge computing, as in the edge being your own computer. So normally you would run it in any of the server environment I mentioned, but here we are letting people try out everything in the browser. So you get a text editor where you can express your domain models. In this case, we have product, and product is associated with a department, and department has a bunch of products. There are some rules such as product can be seen by admin users, but only by normal users only if it is published. Similarly, we have rules such that purchase price may be seen only by admin users. Now, if we execute this, you will get back result. In this case, you are getting smartphone, which is published, as well as laptop, which is published. And in the other department, you get a couple of published products. If you try to ask for things that you are not supposed to, so here purchase price, you will get not authorized, because the current user is anonymous user, and an anonymous user cannot access purchase price. So what we can do is we can simulate login. So in this case, we are saying, let me become admin. And now if you execute the same code, not only you get purchase price, but you also get unpublished product, such as this headphone. Now, if you were a normal user, and suppose we had changed the rule, and if you were to execute it, then you would get back purchase price as well. So depending on how you express your rules and who the user is, you can get access to certain aspects of your product. So everything that you see here is running in the browser. So this part where this code is looked upon through the Exograph builder, and it produced that intermediate representation, that is running in the web browser through WebAssembly. The resolution where query is transformed into data, that is running in the web browser. Not only that, the Postgres server is also running in the browser through PGLite. So when we started to look at Exograph and wanted to make it available on edge computing, we had some challenges, and I want to walk you through that quickly. So one, in a way, if you look at our code, which is available on GitHub, we can put the code into like effectively two buckets. One is a computational code, such as taking the XOR file and converting into its model, parsing and validating GraphQL query. So the query that I typed, for example, take that query, make sure that it is correct according to GraphQL spec and according to our schema. Then take that GraphQL query and map into SQL, for example, if the query is related to Postgres database, or even validate JWT token so that we can make sure that the user is who that it claims to be. All that code just worked. We had to make no change. Initially, we thought like we would have to actually go and deal with lots and lots of aspects, but that part just worked. This is testament to like how good Rust ecosystem is when it comes to supporting WebAssembly. There are other parts, however, and this is where the sandboxing comes into picture. So system interfaces, such as we want to deal with clock. So there's an interface, there's a data available called std time instant. The one that is available from standard library just doesn't work. In fact, it panics if you try to call any method. So what we had to do is we had to use an alternative implementation through this web time create. So you will see if you look at the Exograph code, this selection based on target family is a very common aspect that is throughout the code. Then comes to Postgres, connecting to Postgres. So normally when you want to connect through to Postgres, you would go give it a URL and you will get back a client and a connection. Then you just work through that. The things are a little bit different in the edge computing environment because of sandboxing. So you do not get to give a URL and just immediately get back a connection. Instead, you have to use Cloudflare specific APIs. So in this case, socket, give it the host and port of the Postgres server that you want to connect to, and you get back a socket. This is a raw socket. It's just a connection between the server, edge computing node, and Postgres. And once you do that, then you want to lay over the Postgres protocol by calling this config raw, connect raw. And then you get back a PG client and a PG connection. And the third thing where you have to again do a little bit different. So normal code, you would use just Tokyo spawn and give it a PG connection. Here you have to use an alternative implementation available by Wasm BindGen, which essentially does a bridging between the expectation of async Rust and availability from platform, which is JavaScript futures and async mechanism. There are cases, however, we had to go and contribute back to the ecosystem. For example, Rust Postgres, as it existed back then, did not work with external pooling. I will talk about pooling in a bit. So we had to make a contribution, add a new API to it, and that is now merged. So if you will use Rust Postgres, you don't have to deal with this issue. Similarly, when we wanted to deal with OIDC JWT validator, which is what we use for authenticating using OIDC, we had to make a couple of adjustments, the runtime as well as the standard time that I showed earlier. Similarly, when we wanted to make it work in browser, we use tree-sitter parser. So we had to make some adjustment to it to make it compile to WebAssembly. Worker RS, which is a crate available for Cloudflare Worker, few adjustment, and so is for Deadpool Postgres, which is a pooling solution. So what is essentially happening in this space is more and more projects are trying to target their Rust system to WebAssembly. And in that process, either things already work or they end up contributing the way we did it. And in a way, we are pushing forward the ecosystem so that it becomes easier and easier to target Rust to WebAssembly. We did face a couple of challenges. And one of those is the reason you want to edge is you want latency to be minimal. You want to connect to nearest node, and that characteristic needs to be maintained. So what we found is latency, the cold start time, is pretty sensitive to module size. So we did an experiment where we took a Hello World application and essentially just added dead code to it. And what we found is things are okay until about 700-800 kilobytes. And then it starts to go, the response time starts to go quite linearly. So our goal should be to minimize the module size as much as possible, and then we'll get better latency. So in our world, we already had this separation between builder and runtime, which really helped because we only had to focus on making sure that the runtime part is targeted to WebAssembly and it is done as efficiently as possible. During our experimentation, we also found that if you have the bundle size in which the WebAssembly code could be reduced, even at the expense of some additional data code, data portion, then it actually overall it becomes a win. So what we are now looking into is, can we go and make our XOR file bigger, essentially add more information to it, if that helps us to reduce the size of Exograph runtime. And there are a couple of ways we can do it. One is we can support only predefined queries. Usually in GraphQL server, you don't know what kind of queries will be made. GraphQL ecosystem itself is going towards persisted queries or trusted queries. These are essentially predefined queries that server will allow to be made. And if so, then we can, rather than computing. So right now what happens is if you get GraphQL query, we look at the query. After parsing, we compute what SQL needs to be performed, what SQL needs to be translate into, such as join, selection, CTEs, etc. So rather than doing all that logic and then therefore take the attendant code, we can do a lookup. So look up the query, get the query plan, make sure the variables are appropriate, and execute it. Now, all kind of queries cannot be mapped in this particular nice world. So we may have to nudge users, guide users to defining queries that can be mapped. Essentially, we need to warn them that, okay, if you use this kind of query, then your bundle size will be bigger and latency will suffer. Rather than that, use different style of queries. We also use a couple of tools. So Wasm Opt and Wasm GC that allows you to optimize the size as well as eliminate dead code. At some point, you will want to understand where the size is coming from. So we like this Wasm Phobia tool. So what you do is you drag and drop your Wasm file over there, and it will give you essentially a flame graph of who is contributing how much. And then you can examine it and figure out if that makes sense or can use an alternative implementation. One of the other challenge we faced is connecting from our Exograph runtime to Postgres. So normally, if you want to connect to Postgres and through SSL, you usually have like about 7 hops that you have to make a connection. So it takes quite a bit of time to make a fresh connection. And common solution is to use a pooling, right? So you have pool where first time you will have the cost, but then later on you will just get the existing connection if there is one. When we tried this, because this is what we do in for all our other runtimes, target runtimes, we faced an issue where we got in this error, which essentially says that you may not hold onto an outgoing connection between two requests. So the solution was to use Hyperdrive, which is a pooling solution made available by Cloudflare Worker. And so this allows, essentially this shifts responsibility from pooling from runtime to edge itself. And this will keep on to keep warm connections, and it will give you essentially local connection between Exograph runtime and Hyperdrive. And the result was when we didn't use any pooling, we get about 345 milliseconds round trip response time, cold round trip response time. With Hyperdrive, that reduced to about 60 milliseconds. So it's a pretty good win.
So it's amazing to see the success that Ramnivas and the Exograph people had moving their application from the cloud into the browser or intermediately in the Cloudflare Worker space. These represent very different environments with very different expectations, but they were all able to provide a sandboxed environment, and things like database pooling, which may normally be part of your strategy, aren't necessarily directly available, or at least not in the same way. And they had to make some changes. They also acknowledged that they had to make some changes elsewhere. And yet overall, the experience was quite positive given the close collaboration between the Rust and WebAssembly worlds. But we don't want to spend our time tracking this down, and we don't necessarily want to make everybody use Rust in the same way. And we don't want to repeat these APIs in all these different other hosts and from other languages. So the Wasi initiative, as part of the WebAssembly platform, is a collection of service interfaces that will provide a consistent set of capabilities that will make this kind of thing easier in the future. The idea is that we don't want the application to be generally aware of the environment that it's running in. It just needs to be able to express its needs as far as what it requires of the host environment that's running it. And if its needs and what the host is willing to provide come, into nice synergy, then this kind of thing will be even easier as we move forward. And you can target hosted applications in sandboxed environments. You can have the same application recompiled to run as a native application on a normal operating system. You could run in a unhosted bare metal data center, or even in the browser with various kinds of polyfills. But the application itself will be written against APIs that's aware of. So Ramnivas mentioned a couple, access to sockets and access to clock information as being some of the things that they had some issues with and had to kind of find a solution from. But what we see is the Wasi interfaces are evolving to support a wide range of capabilities, like low-level I/O, or the ability to keep track of times and schedule things according to clock times. So what we're going to see moving forward is that rather than just using WebAssembly modules, people will evolve to use WebAssembly component models, which allow them to express their needs and what they require from the environments that they provide that they run in, and the capabilities that they provide as well. And that's going to tie everything together and make this even easier to be able to do both high performance systems in a wide range of environments that are still safe and sandboxed. And so security and performance don't have to be forever in opposition to each other. And as we've seen so far, and we'll continue to see, we can get both at the same time. Thank you very much, and we hope you enjoyed this.